Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 7.2.2, starting with problem number 49. We've got three lines here. So compare the graphs of lines A, B, and C. Which line has the greatest slope? And we're looking for the one that's the steepest. That's the one that increases the most per unit on the x-axis, whatever those units have to be. So A is definitely going to be the greatest slope because that's the steepest line. It's the steepest increase. What is the y value of A when x is equal to 2? So when x is equal to 2, the y value is right there. That would be about 5. And compare the slopes of lines B and C. So how do we figure out the slopes of these lines? Well, let's look for some lattice points, and let's look at some growth triangles. So line B looks like it passes through 6, and it looks to go 1, 2, 3 units to the left. Up 1, does it? I'm not quite sure if that is, if I went down 1, 1, 2, 3 to the left, down 1, 1, 2, 3, down 1, 1, 2, I'm not sure that's it. I think this is it right there. So sometimes it's not real easy to see those clear intersections, but I think that's what it is. So you go 1, 2, 3, 4, 5 to the right and 2 up. Let's check if we go down 2 and then 1, 2, 3, 4, 5. Yeah, that's it. So B has a rise of 2, a vertical increase of 2, and a horizontal change of 5. So that would be 2/5. C is the same thing. You go 1, 2, 3, 4, 5 to the left and 2 up, or 1, 2 down and 1, 2, 3, 4, 5 to the left here. They both have the exact same slope ratio. And that really literally means that those two lines are parallel to each other, because two lines that are parallel to each other will have the exact same slope. Lydia drew a graph of 4 athletes in the final part of the triathlon, the 10-kilometer run. She found the slope of each runner's line. Her results are listed below. So runner A had a slope of 2.6, which I converted to 1/3, which in decimal form is 0.3 repeated. Runner B had a slope of 3/7, which rounds off to 0.43. Runner C has a slope ratio of 5/12, which rounds up to 0.42. And then runner D has a slope ratio of 4/10, which in decimal form is 4/10, 0.4, which I could put a 0 there just so that they all have the same number of digits. So 0.33 repeated, 0.43, 0.42, and 0.40. So list the runners from slowest to fastest. So the slowest is going to be the slope ratio that has the lowest decimal equivalent. So that would be A. And then it would come B would be 0.40, and then C, and then B would be the fastest of all of them. And if you were to show that on a graph, you know, taking those slope ratios, you would see that B is the steepest line. That's the first one that would get to the 10, are these kilometers? Yeah, B would be the first one to get to the 10-kilometer mark because it's traveling at the fastest speed, then C, then D, then A is at the slowest, is the slowest speed, so that would take the longest to get there. All right, if a car is parked on the side of the road and is not moving, what is its speed? Boom. What would it look like on the graph? Well, on graphs, if you are not moving, stop it. Let me actually go back to this graph here. And let's get a line, and how about we'll just use a black line. Okay, so you're not going anywhere. If you're just on the side of the road, let's say you're 4 miles away from your house, and you are not going anywhere, time increases. It keeps going on, right? So it's, you're not going anywhere, you're not getting closer to home, you're not getting farther away from home, you're still 4 miles from home, but time increases. So this is this is a zero slope, right? The change in y over the change in x, while x is changing, you could say to get from here to here, x increases or changes by 8, but y isn't changing at all. So that is a slope of 0. The class advisor was helping students plan an end-of-the-year trip. Students were surveyed about their choices. The results are shown at the right. So the Science Museum, 23% of the students wanted to go there. 29% wanted to go to the amusement park, and 18% wanted to go to the golf, miniature golf. And I'm sorry, I don't believe these numbers. Just go ahead and add all those people to that. Everybody's going to want to go to the amusement park. Let's not fool ourselves, but whatever. That's a different issue. Okay, so what percent of the students chose the water park? Oh, I guess some of them might want to go there as well. So all three of these, when you add them up, add up to 70%, which means the rest of it has to complete the circle to get up to 100%, and so that's why the water park is 30%. Which two results are very, very close? Well, the water park and the amusement park are only 1% apart, right? One's 29, one's 30. And write a recommendation to the class advisor regarding what the next step would be. All right, so this is your own opinion. You could say, all right, well, the one that won was, what are we going to call these? The end of year trip one is the water park because it got a majority of the students. None of them got over 50%. And so my choice would be, let's go ahead and get rid of the Science Museum and the miniature golf, and let's do it again. And these people have to decide whether they want to go to the amusement park or whether they want to go to the water park. And then you'll get a clear idea of which one is the favorite. So that's just my suggestion. Do whatever you want. All right, another 5D problem. Solve the problem by defining a variable, writing an equation, and solving it. Write your solution in a sentence. So the number of students attending the fall play was 150 fewer than 3 times the number of adults. So it looks like we've got students and adults are our two variables. Since the number of students is being compared to the number of adults, we'll make the adults x, and then we'll write the expression for this relationship. 150 fewer means it's being subtracted away from 3 times the number of adults. So whatever that number is, triple it, then take away 150. So we can do the guess and check process, but I think it would be better to solve this algebraically. Now, the last piece of information we need is the fact that there are a total of 1,778 tickets. So we know when you add the number of adults to the number of students, or I'm sorry, yeah, the number of adults to the number of students, you will get the total of 1,778. So you combine like terms. I'll go ahead and show this work here. Combine like terms to get 4x minus 150 equals 1778. Then we want to get our 4x's by themselves. So we add 150 to each side. Because literally what we're asking here is, if 4x minus 150 is equal to 1778, then what was the 4x before we took away the 150? So let's add them back in and see what that was. And that ends up being, what is this, an 8? That's 12. That's 9. This is a 1. So now 4 times something equals 1928. So let's take 1928 and divide it by 4. And that's going to tell us what our something is. And I see it right there. But let's just show it on the calculator. 1928 divided by 4, 482. So the number of adults that attended was 482. So I'm going to check this and make certain that that's correct by taking 482, and then I'm going to multiply that times 3. Then I'm going to take that answer and subtract it by 150. So 482 times 3 is 1446. Now I'm going to take away 150 from that because that's what it said to do up here, and I get 1296, which is this number right there. So when you add those two together, if I indeed get 1778 by adding 482 to 1296, then I have checked my answer and I've made my decision according to the 5D process, and I can now declare my answer. How many students attended the play? 1,296 students attended the play is the complete answer. All right, below these figures are similar to each other. Use the given information, or use the information given about the links. I'm having trouble reading. You know what I'm supposed to do, right? Okay, so let's just go ahead and find the sides that they have in common. Looks like those two sides could be used, or these two sides could be used as well. But I'm going to write that ratio as 10 over 6. Or, wait, hold on. Which is 5 over 3. Oh, okay. 10 over 6, which is 5 over 3, or use 3 over 5, just depending on which direction we're going. Okay, so let's start with x corresponds to the 9, and x is greater than 9. So we're going to multiply 9 times 5/3 because that's the scale factor greater than 1. So 9 over 1 times 5 over 3 gives me 45 over 3, which is the same as 15. So x has to be 15. And then we see that the 15 here corresponds to the y here. Hey, wait a minute. If this is 15 and that's 15, shouldn't that be 9 probably, since this is 9? Since these two are the same, I feel like those two are supposed to be the same as well. I bet that's the answer, and of course I see it right there. But still, let's go ahead and figure this out now. So 15 has to be multiplied times the scale factor that's less than 1, because y is less than 15. So 15 over 1 times 3 over 5 gives me 45 over 5, and 45 divided by 5 is in fact 9. All right, so I feel like we should be experts now at determining scale factor and determining whether or not we should use the one scale factor or the other, depending on what information we need to find. And that ends our homework for today. All right, so let's move on to the next activity.
Hey, feeling good